Hello and welcome to part 2 of the NPV and the IRR. In part 1 we discussed some preliminary concepts, and these concepts had to do with the time value of money, basic principles of the time value of money. We pointed out that if you have money today and you earn interest over a period of time, the money is worth more tomorrow. But on the other hand, if you're promised money tomorrow, it's worth an effective value today, and that could be calculated using the discount rate. So we looked at a couple of examples of how that works. Well, the net present value is one way to incorporate the time value of money, not just to evaluate something simple like one cash flow. In this case, in the previous example, we looked at the value of $100 promised a year from now, how much that would be worth today. If you look at the net present value, and you're looking at it in the context of evaluating a project, you're typically looking at multiple cash flows over a period of time, and you're discounting all of those to the present. In other words, calculating the effective value today of cash flows you're expecting tomorrow. So let's take a look at this from the example in the text. This is a 5-year project. It has a projected cash flow of $15,000, $25,000, $35,000, $20,000, and $15,000 for the next 5 years. But it cost $50,000 to implement the project. All right, so in this case, in the case of the present value, the cash flows you're expecting in the future will be discounted to the present, so you can calculate the effective value of that today by taking future promises of money, which is what the project is promising, discounting them to the present. Okay, so that's what we'll do with the future cash flows, and we will calculate the present value of those. Now, there is a cost of implementing the project, and that's $50,000. That's how much is paid today. So, in essence, what you're doing with the net present value, and it's called net present value because you're netting out what you're paying out today, and you're netting that against what the project promises to deliver in the future, discounted to the present. That's where you get this mathematics. It looks rather complicated, but as we're going to see, it's very easy to do in the spreadsheet. Okay, the project NPV, you take the initial investment and then the sum of the future discounted cash flows. That is what that sideways M is saying. That's a summation. Your summation is of future cash flows divided by 1 plus the discount rate, or the required rate of the return, or interest rate, as we've described it. So let's slide over here in the spreadsheet and look at a typical NPV calculation. Notice I have IO. According to the problem, you pay $50,000. That's what you initially pay to implement, and I've got that recorded here. And I've recorded the future cash flows, 15, 25, 30, 20, and 15 according to the problem. Now what have I done with the discount rate? The rate of the return, the interest rate, the discount rate is given as 20%. So remember, according to the formula, in 1 year's time, it's simply 1.2 for 20%. 2 years' time, it's 1.2 raised to the second power. In 3 years' time, 1.2 raised to the third power. 4 years' time, 1.2 raised to the fourth. And 5 years' time raised to the fifth power. Then, if you look at the formula in the spreadsheet, I've divided the cash flow by that discount rate. You see R19 divided by R20. That's the cash flow divided by the discount rate. And here we have it again in period 2, S19 over S20. So you can see it's a simple matter to enter in your cash flows, enter in the discount rate factors, and it's based on the period. In this case, period 1 through period 5. And then we divide the future cash flow by that discount rate, and this is what you see in line 21. Now I'm going to sum them. So I take each of these future cash flows that are discounted to the present and sum them up, in which case I've got 62,895. Now, to calculate the net present value, I take that number and combine it with the initial outlay, and now I have a total, and that total is 12,895 and some change. Okay, so that's a positive number. So what is that telling me? First of all, when you get an NPV result, you could either have a negative result, a zero result, or a positive result. Negative means that your project is going to earn less than what you could have earned if you just put that money in the bank or secure financial instrument. So a negative NPV you should avoid. A zero NPV means your project is going to earn as much as it could in a secure investment regardless, so it's a question mark. Positive means your project is going to earn more than if you had invested that money in the bank. Okay, so you should look for positive NPVs. All right, now I'm going to demonstrate a couple of things really quickly here. First of all, you should know that the higher the discount rate, the more difficult it is to justify a project. For example, what if I said we had a 35% discount rate instead of 20? Okay, so let's put that in each case. 35, 35, and 35. Okay, now notice the NPV is negative. This tells me if I required a 35% return on this project, or that's how much I could earn in an alternative investment, this project would have a negative NPV and I should not do it. Well, 35% is worse than credit card interest, so that's kind of an extreme number, but it just gives you an example that the higher the discount rate, the higher your corresponding cash flows need to be in order to justify the project. So this ends up being negative. All right. Now, of course, if you had a very low discount rate, let's say 1%, then the project is going to be very easy to justify. So that's a word of warning that when you see that the project is justified based on the NPV, the first question you should ask is, what discount rate is being assumed? A low discount rate makes it easy to justify the project. A high discount rate makes it very difficult to justify the project. So there you have it. Here with a 1% discount rate, now you've got a very, very positive NPV. All right, now let's talk about inflation. So let's go back to the original discount rate, which was 0.2. And which means just a 20% discount rate. All right, I'm going to go ahead and copy and paste this in so that all of these have 20% discount rate. Let's see, hold on a second here. Get that done. We'll go back to where we were with a 20% discount rate in each case. Sorry, that's 1.02, not 1.2. Okay. All right, and in your spreadsheet, it's just a matter of entering these in. Now we're back to 1.2 in each case. All right, and we're back to our original NPV of 12,895. Now the question is, what happens if you if you assume 3% per year inflation, for example? For that, you would just add 3% to each of these. All right, so 20% becomes 23% in each case. I'm going to go ahead and add this in. And what does this do? It increases the discount rate, and because of that, you should see the NPV number become less positive. Now, it's still positive, but it's less positive. Okay, so to sum up, high discount rate means it's more difficult to justify. Low discount rate, easier to justify. So be sure and check for that. To include inflation in your calculations, just add that to the discount rate. Now finally, I want to talk about the IRR. There is a complicated formula for solving the IRR. IRR means the effective return rate of the project. What would the project effectively return compared to some other project? It's a slightly different way of looking at it. Instead of using a complicated formula, what you could do is find out what discount rate produces a zero NPV, and once you do, that's the IRR. Now we know that 35% went negative. Let's just go to 25% and see what that does. Okay, we're just going to plug the value of 25% in and see what that does to our NPV. And again, the point of this is we're going to try to drive it down to 0. If we drive it down to 0, we know that that's the IRR. Okay, we still have a positive NPV, so now I'm just going to bump this up to 30%, and let's see where we're at. 30, 30. We know that 35% went negative, so 30% I imagine is going to be close to 0. Here we see it getting down to 1,000. Okay, so we're about $1,000. We know 35% is negative, so let's go to 32% for each one. 32, 32, 32. One more 32. Okay, so 32 is a bit high. We see the NPV's gone negative, but it's not a real high negative number. So I would estimate that probably at about 31% is the IRR for this project. And this just means what is the discount rate that sets the NPV value to 0. Once you figure that out, that is the IRR. And we see here we're down to about a negative 100, so that's really close. Okay, positive 42. So almost it's between 30 and 31% is the IRR for this, because somewhere in that area the NPV becomes 0. In this case it's slightly positive. So that tells you the IRR. So just to summarize what we've learned then, in the net present value, even though the formula looks a bit complicated, you're just taking your initial input, the summation of future cash flows that are discounted to the present, as we've learned how to do, and you add them together. If the result is 0, that means that your project returns as much as it would if you put it in the bank. If it's negative, it's a bad idea. It destroys value. It's worth less than what you'd get if you put it in the bank or secure a financial instrument. If it's positive, that's a good thing. You should also remember the higher the discount rate, the more difficult it is to justify the project. The lower the discount rate, the easier it is to justify the project. To add inflation, you just add the inflation figure to your discount rate. So as I showed you earlier, 20% in the case of 3% inflation a year becomes 23%. Finally, let's remember that to find the IRR, even though if you look that up, you'll find the IRR is a complicated problem to solve mathematically. But you can back into it by plugging in values of discount rate that produce an NPV of 0. Once you get to an NPV of 0, what you have is the effective return rate of the project, or the internal rate of return. So some companies compare projects based on IRR. So that's a way to do that, to calculate the IRR, but doing it in a very simple way using a spreadsheet. So that concludes part 2 of the NPV and the IRR. With that background, you should be able to solve the problems in this module.